Question number 6, and you should do this on your own before watching me do it. The store is making a profit of $50 per unit sold at its current price and is selling 200 units. So for each $3 increase in it, my English wasn't the best on this test, but nobody really seemed, one or two people asked questions and we clarified it. So it's not an increase in price, although if you increase the price and your costs don't change to produce, that should be an increase in profit as well. So anyhow, the profit's increasing $3 per unit. For each of those that we decide to do, we're going to sell 4 less units. So find the price that will maximize profit using calculus. There's, of course, a graphing way to do this as well. We'll use that to check. Let's just see where we're at. Our total profit. Right now, we're selling them for 50 bucks each times 200. Okay, well, let me get out of the graph here. 50 times 200, making 10,000 bucks. And it says if I increase the profit $3, so okay, that would take me up to $53. I'll sell 4 less, 196. Seems like that increase was a good idea. Our total profit has gone up 388 bucks. What if I do one more? Well, okay, you'd have $56 and 192 for our units. We could check one more. And we have 10,750. So we should just keep increasing profit forever, because look at this, we're making more money every time we increase. Well, clearly eventually this is going to go to 0 and we'll make nothing. So there must be a maximum out there somewhere. Now this would actually work, and I do show, and maybe perhaps later I'll put one up on Excel, where you just drag this chart down and eventually you're going to find where it starts going back down, and then you could even change your increments and narrow in on a better solution, which for business purposes would be fine, but we are supposed to use some calculus. So let's try and write a function for our total profit. Let's call it total of x. Well, it's very easy to see what's happening. When I did nothing, so my variable might be 0 here, would be one way to look at it. We had 50 times 200. When my variable be 1, one of these increases, this went up by 3. So 50 plus 3x would model the price we're charging. The profit we're making, I guess, is a better way to say it. Put in a 0, I get 50. I put in a 1, I get 53. I put in a 2, I get 56. So you can always check a few of these to make sure it's working okay. Times 200 minus 4x. Same thing, when x is 0, I have 200. X is 1, 196, and so on. We see the slope showing up in these. So that's my total profit. You could take the derivative right here using the product rule, or maybe I'll reduce this just a tad. 50 times 2,000 is 10,000. I get plus 600x minus 200x minus 12x squared. Well, let's reduce it one step further. I've got a couple lines I can still work. 10,000 plus 400x minus 12x squared. You could graph this. Let it be your y equals graph. You have a maximum finder in a calculator. Perfectly good thing to do to check your answer. But obviously we're trying to use some calculus here, so let's use some calculus. T prime of x is equal to derivative of a constant is 0, derivative of 400x is 400, derivative of negative 12x squared is a negative 24x. And we're doing the derivative to set it equal to 0. There are 3 types of critical points, and we want to stress this one more time as review. Derivative equals 0, derivative undefined, which never seems to really happen, and the endpoints. This one, you could argue the endpoints, you could go negative with this process. You could charge less than $50 and sell perhaps more than 200 if the model holds up that way. So maybe you could say we could go all the way down to 0, which is probably not a great solution. You could go on forever. Of course, eventually you're selling none. And we'll look at the graph in a moment. Well, so we set this equal to 0. Very easy to solve. 400 equals 24x. And x is equal to 400 over 24. So there's your answer, 400 divided by 24. We should do 16 2/3 of those increases. 6 forever increases. Now, since if you look back at where we came from, that's not a price. That's an x variable. It's related to the price and the number we're going to sell. So if I plug that in, I'll have 15 plus 3 times that, 50 rather, plus 3 times, I can do second answer here. No, that didn't work out. So, okay, well, let's just do it. 16.666 forever times 3 plus 50. And I get basically $100. Should be charging $100. I will sell 200 minus 4 times that x. I'll sell 133 1/3 of these units if that's possible to sell a third. Units sold, and then multiply the two together and you'll have your total profit.